Hello students, welcome to RLD Academy. In this video, we are going to discuss how to find range of functions. In particular, we will discuss two problems from IIT JEE main exam paper. We will solve it thoroughly. And further, I will give you one homework problem for practice purpose. Consider the first problem. It is given that, so now this problem is taken from 2019 paper. Now one function is mentioned here, f of x equals to x upon 1 plus x square, and where x is real. We need to find the range of f. 4 choices are given, but we will look at the choice later. Let us first find out the range of this function f of x. Now, before discussing particular problem, we will try to understand what is the range of function. If f of x is given, where x is independent parameter, so we can plot this f of x with respect to x. Suppose this is the shape of f of x. For any function f of x, we can find one level which will indicate its maximum value. So suppose this is your maximum value, f max. Similarly, we can find its minimum value as f mean. So if I can understand these two levels, f max and f mean, then obviously the function value f of x will lie within f max and f mean always for any x value. Thus, the range of the function f is defined as within this interval f mean to f max, including f mean and f max. So we will use one third bracket here, and we will use third bracket this side as well to indicate that the range is from f mean to f max, and both are included. Right? Now we will consider the particular problem. F of x equals to x upon 1 plus x square. So this is the function given here. Now we need to find out its maxima and minima. We can use calculus, but if the function is given in this form, one numerator and denominator, and if numerator or denominator both are either quadratic function maximum, then we can use one tricks. Just follow this one, what I am doing. So I will consider that this value of this function is y, suppose. Then what I will do is for this one, I will take reciprocal of this one. This is 1 plus x squared because this is second order. Okay, 1 plus x squared, and this is coming here x. So this will become now 1 upon y right side. Now what I will do, I will multiply this x to the right side. So I will get 1 plus x squared equals to x upon y, right? Then I can get one quadratic equation like this. So x squared minus x upon y plus 1 equals to 0. So this is your quadratic equation. So already I have said that we need to find out minimum and maximum value for this function. But remember that the x should be real. For all the real values of x, we need to find out maxima and minima. So here we will apply one tricks. We will assume that the value is y. Then from this quadratic equation, we will try to understand when we will get real solution. Because x is of course is real. So if I solve this equation considering one value y, then x should be real with one condition. What is the condition? So a solution of x will be real if discriminant d is more than equal to 0. That is known to us. So what is discriminant? If I consider one quadratic equation like ax squared plus bx plus c equals to 0, in that case we can define the discriminant as d equals to simply this b squared minus 4 times a into c. So b square minus 4ac, that is the discriminant, that discriminant function we can compute, and we can set this is equals to or more than equal to 0. This is the condition for x should be real, right? Now for this one, this is b is here minus 1 upon y, thus b square is 1 upon y square minus 4, a is 1 and c is also 1, so this is 1 1. So this discriminant part should be more than equal to 0. In other words, 1 upon y square should be more than equal to 4 because this is 4 only. Now I can take reciprocal of this one. So y square we can write as less than equals to 1 upon 4. So if I take reciprocal on both sides, then obviously this positive, this one greater than equal to will become less than equal to. Okay. Now y will be equals to then 1 upon square root 2 or plus or minus. Thus the range would be y should be within minus half to plus half, including equal sign, both the values, right? Thus its range will be from minus half to plus half, including these two values. So the option A is correct here. Okay, so we have solved this problem, but we will try to get more about these functions. We try to understand the plot for this function. Now try to get some visualization of this function. What we will do? So you see this function f of x equals to x upon 1 plus x square. So x in numerator and denominator is 1 plus x square. Suppose if it is not there, if it's only x, then the function will be f of x equals to x. It's a linear passing to the origin and slope is 1, right? So this function f of x, you can write x times 1 upon 1 plus x square. So I can say that it's a product of two functions. One is f of x equals to x, other function is f of x equals to 1 upon 1 plus x square. So this thing we'll consider. So this is x times 1 upon 1 plus x square. So what is the plot for this 1 upon 1 plus x square? You can see that this is an even function. Go 1 upon x, 1 plus x square, the square term is there. So positive side and negative side it is symmetrical. And as x is increasing, denominator is increasing, that's this value is decreasing continuously, it is becoming 0. Okay, so this is the plot on both sides, it's even function. And remember, this one f of x equals to x, it is an odd function. So whenever one odd is multiplied with even function, the product will become again odd. Okay, so this product, point-wise product, we can have to consider like this one. So this is 1 here, it is 0 here. So 1 into 0 will be 0. It implies that f of 0 should be 0. Similarly, at this point, suppose, so whatever value it is there, okay, at this end or at this 1, suppose at 1 this value is 1 and this value is 1 upon 1 plus 1 square means 1 by 2. So this value is half and this value is 1. So 1 into half, it will become half. So product should be half, right? So we need to get the product of these two functions. Then how it will look like? You see. So this is the function. So right side is, now because of this one initially it is growing, but as this function is reducing, so ultimately this product, the product is going towards 0. Because if x is very large, in that case x upon x squared will become 1 upon x approximately. So x is infinity, means 1 upon infinity, it will become 0. So at infinity it will go towards 0. Similarly from the further left hand side, it is also going towards 0, right? So this is the function, this green one, it is for f of x, this one x upon 1 plus x squared. So from here easily we can see that what is the maximum value. So you can understand this is the function, and for this function I have, this is the maximum level half, and this is the minimum level, it is minus half. Thus the range is minus half to plus half. Now we will consider the next problem. And before going to the next problem, if you enjoyed this video till now, can you please press the like button? And if you wish to get this kind of videos, then you can press the subscribe button and bell icon. I will be adding lots of videos in this channel. Now consider the second problem. The second problem is this one. F of x equals to x squared plus x plus 2 upon x squared plus x plus 1, where x is real. Now we need to find out the range of this function. So how to compute this one? And this problem came in 2003. Okay, this is not very difficult, very easy one. Without calculating anything from the, we can choose one correct option. Okay, by some logic. Okay, so what is the logic behind that? So you can see that this minima is given always 1. So don't bother about this minima value. Okay, all are 1. Now what is the maxima? Will it go to infinity? So at infinity, x equal to infinity. So this will be negligibly small, x and 2, all those things. So x square upon x square. At infinity it is again 1. So at infinity it is not going to infinity. So there is no chance. Okay, and again there is not kind of this thing that, so this is always positive. You can see the x square plus x plus 1, it is always positive. Okay, for positive values of x. Right? So we can show these things. So its value may not be infinite, and again, but again you can see this one. So this value, if I consider at x equal to 0, what is the value? So 0 plus 0 plus 2, this is 0 plus 0 plus 1, so it is 2 by 1. So f of 0 is 2. Okay, so at least it should be more than 2. Not, it cannot be more than 2, the maxima. Maxima should be more than 2 because more than or equal to 2. But it cannot be less than 2 because f of 0, easily we can see that it is 2. So this choice, this one, 11 by 7, it is not more than 2. Okay, this is also not more than 2. So these two are not correct. This also infinity is not reasonable. So only choice is C. Okay, so that is by argument, without doing anything, we can see that this option is correct. Option C is correct. Now we want to analyze this function in proper way. So what we will do, f of x is this one. Now we can rewrite this. So you can see this numerator and denominator is very similar, only the change is here, it is 2, it is 1. So if I replace this 2 by 1 plus 1, right, then we can consider this 3, this one and this one will be similar, same, exactly same. So this by this will cancel, it's 1. Thus these two will cancel, then I will get 1 here, and here it will be 1 upon x square plus x plus 1. So here you can see numerator is 1 and it is x square plus x plus 1. So this is one quadratic equation that also we can solve its maxima and minima value, right? And it's, if it is always positive, then obviously this function is more than always 1. That we need to understand first. But again here we can assume that okay, x square plus x plus 1 equals to y, and then previous approach we can take. But for this one it is very simple. It is only one quadratic equation that we can manipulate. So you can see we can rewrite this one as, this will remain same 1, here it is x square, and this x I can rewrite as 2 into half into x, and then half square is 1/4, and then we'll adjust this one is 3 by 4 to make it 1. Okay, so this one is replaced by 1 upon 4 plus 3 upon 4, but this one, this 3, x square plus 2 into half into x plus half square will give you x plus half that whole square. So thus it is 1 plus 1 upon x plus half that whole square, and it is 3 upon 4. And you can see that this value is always more than equal to 0. It is always positive. So as it is always positive, so this total value should be less than equals to 1 upon 0 plus 3 upon 4. Thus it should be less than equals to, this is 4 is coming here, 4 by 3, so 7 by 3. So maximum value of f of x is simply 7 by 3. It is very easy to find out. And minima, that you can understand that at infinity. So it is 1 plus something, this 1. Okay, and this value is always positive. And when this value is maximum, that time f of x will be minima. Okay, and this maximum value of this one is infinite. At infinity, plus infinity or minus infinity, both sides, this value will become infinite. So 1 upon infinity is 0, thus its value will become 1. So its minima is 1 and maxima is 7 by 3. So maximum level is 7 by 3 and minimum is 1. Thus, the range is simply 7 by 3, and this one already I have said that it should be minima is 1. Right. Now, this is the option. The option C, as I said that it is going to be correct. So with the logic also we have shown that C is correct one. Now I want to give you this function safe. So as both the one x squared plus x plus 2, this is one parabola. So that parabola we can show here. So I can consider f of x equals to multiplication of these two. One function is this parabola, another one is 1 upon that parabola, this function x squared plus x plus 1. So that one, the shape is like this. So 1 upon x squared plus x plus 1. So I need to multiply these two, this function and 1 upon x squared plus x plus 1. So if I multiply these two functions, I will get my desired function f of x. And this shape will look like this. So this is a shape. If the product is there, so these two product will give you this green shape. This is the final function f of x. And from here, this is the maximum level and this is the minimum level. Minimum is 1 and maximum is here. And this value we have computed, it is 7 by 3. Okay? Fine. So now I will give you one homework problem. Can you find the range of this function f of x equals to x squared upon x squared minus 2x plus 2. Try to solve this function, try to solve this problem, find the range of this function and share your answer in the comment section. Let me know that you have understood this concept. Right? I'll surely reply to your comments. So if you enjoyed this video, please press the like button. If you wish to get this kind of videos in future, please subscribe the button, subscription button and also bell icon. So thanks for watching.